Hello folks, and welcome to this lesson on the organic nomenclature of alcohols and ethers. By the end of this lesson, you should be able to name and draw organic compounds that contain alcohols and ethers as side or parent chains. So starting from this lesson, we're going to be talking about several different side chains or several different functional groups that have oxygen in them. The first one we'll cover is going to be alcohols. Alcohols contain hydroxyl groups, and those hydroxyl groups are OH groups. You might be able to see where the name comes from. Your OH minus anions are hydroxide ions, hydroxyl groups, and so on and so forth. Now, opposed to most of what you've seen so far, alcohols actually have much stronger intermolecular forces than your regular alkanes or alkenes are going to have. And that's because of that hydroxyl group. If you take a look here, this is an oxygen that also has a hydrogen to it, and so you're going to be able to perform hydrogen bonding when it comes to alcohols. Of course, things like branching, where the hydroxyl group is, and etc. and so forth, is going to affect the intermolecular forces when you're comparing it to different alcohols, but compared to most of the hydrocarbons you've seen before, alcohols do have much stronger intermolecular forces. So much so that even a lot of the smaller ones that you see, like methanol and ethanol, they're pretty much liquid at room temperature. So here we start seeing that you can take some of these functional groups and name them as part of the parent chain as the most important functional group. And in some cases, you're going to see them named as a side chain instead, sort of like with those phenyl groups. So if a hydroxyl group is your most important functional group, then you're going to name it as a parent chain. You change the ending, that very last E, into an OL. We have a little bit of funkiness with when you have more than one hydroxyl group as that alcohol. So an octanol, which only has one hydroxyl group, is going to be octan 1-ol. You've changed that very last E into an OL. But then if you have more than one OH group, then you put the E back in and then it goes diol. It's one of those weird things again. So you're going to do your usual thing of find the longest chain that has a parent chain in it. When I highlight the parent chain in an alcohol, what actually ends up happening is that I'm not going to be highlighting that OH, but the carbon that the OH group is attached to needs to be in that longest chain. And so in this particular case, this is our parent chain that contains our most important side chain, or functional group rather. When we number it, we need the lowest number combination for that functional group. In this particular case, it's symmetrical, so it's not going to matter. We see that we have a methyl group here. Now we put the entire name together. So in this particular case, we're going to start with our side chains. We have a 2-methyl. Parent chain has 3 carbons, so we're going to have a propanol. And because this OH group could have been on any one of those 3 carbons, we have to make sure we indicate that 1, or that 2 rather, in this case. And here you go. So here I have a cyclic one for you. Pause the video and see if you can figure it out. This one isn't all that bad. There isn't much to this hydrocarbon. Our parent chain is going to be that ring. This is the only thing of note, so this is going to be our most important functional group. We want numbering that is lowest number combination for that most important functional group, so that's carbon 1. And so when you name it, we have none of the side chains, so we're going to go straight with cyclopentan. And recall that this is cyclic, we only have that one group. There is literally no other carbon that this group could have been on other than carbon 1, because you name it based on where it is. And so this one does not have a 1, it just goes straight to that ol. Then you have naming alcohols as side chains. So some of the other groups that we're going to be talking about are a little bit more important than the alcohols. And so if you see those functional groups instead, you're going to name the parent chain with that as the most important functional group. OH groups are going to be the side chains instead. So the side chain name is hydroxy. Please note that the name of the functional group is hydroxyl. The name that you use when you're using it as a side chain is hydroxy. You do not have that L. So pause the video, see if you can figure it out. Now, when it comes to this particular hydrocarbon, you could honestly just name it as an alcohol, but for practice sake, let's name it so that it is a side chain instead. So in here, our most important functional group, supposedly, is going to be that alkene. And so we're going to highlight that main parent chain. You're going to do the numbering, and your numbering has to be so that you have this with the lowest number combination. So we're going to start with 1 on the left. Again, we are going to name the hydroxyl group as a side chain. So we have the hydroxy here on carbon 1. So put the name together. We're going to put the side chain names first. So this is going to be 1-hydroxy heptene. And so this is what the name would look like if we were going to name the hydroxyl group as a side chain. Now, because this doesn't really have anything else, you could name it as an alcohol. And so if that were the case, you would name this as heptene-1-ol. Next functional group we're going to talk about are ethers, and they're actually fairly similar to the alcohols that we just looked at, in that it is an oxygen. All the bonds are single bonds that we're looking at. The only difference is that the oxygen is not going to have a hydrogen attached to it. It's going to have another R group. Now, I used an R group when I was showing what a hydroxyl group was. An R group in general is just something else. A lot of these times, these are going to be other carbon chains. So you have carbons attached to it. Those carbons are going to have a whole bunch on them as well, or maybe they don't. Maybe it ends at that carbon and you just add a few hydrogens to it. But it's unknown carbon stuff. So the oxy in the alkoxy is referring to the oxygen, and the alk is referring to some kind of alkane or whatever chain. So that's that carbon chain bit. Now, because we've lost that hydrogen, the intermolecular forces are still going to be stronger than alkanes because you have a much more polar bond between a carbon and an oxygen than you would with a carbon and a hydrogen, but the intermolecular forces of ethers are going to be weaker than alcohols. Ethers, depending on how complicated as they were, used to be named with a different naming system. And so your very, very simple ethers, basically you have an oxygen and very simple chains attached to it. These simple ethers used to be named in a way where you say, okay, you have this chain and you have this chain, and then it's an ether. Now, this being said, we're not going to use this naming method because it's not IUPAC. But if you were going to use a naming method, this is what the name would look like. And so if you do encounter it in some of the older articles that you read, this is how that works. So IUPAC only really names ethers as side chains, and so that's pretty much what you're always going to be doing when you have an ether group. So what you're going to do is you're going to have it as a side chain, and then what you do to the ending is instead of "il," you're going to have the suffix of oxy. So if we take this particular hydrocarbon, well, pause the video and see if you can name it. So this particular hydrocarbon is going to be an alcohol. So this is that most important functional group. So we're going to look for the longest chain that has that functional group in it, which is this one. So from here, we're going to number the carbons. Numbering it from the right is going to give you the lowest number combination for this particular alcohol, the hydroxyl group. And then on carbon 3, we have our other side chain. This has 2 carbons, and so if it didn't have that oxygen, this would have been an ethyl group, but because it does have that oxygen, it's now an ether, so this is going to be ethoxy. So put the name together, start with your side chains, then comes the number of carbons in your parent chain, no double or triple bonds to worry about, and then that functional group. So this one ends up being 3-ethoxy heptene 2-ol. Now, when it comes to drawing, there's nothing super special that you have to worry about when it comes to drawing alcohols or ethers. So that's the end of this lesson. I'll see you next time.